Okay, 8.3, using special factors to solve equations. So you'll see a lot in this is very similar to what we did in 8.1 and 8. Our essential question that we want to answer is, how can you use special products to aid in solving quadratic equation factoring? And so with that, you'll see some of the stuff that we've done in the past in the factoring module now applied to this. Okay, so a quick little review here. So go ahead and factor these problems on your own. And go ahead and pause the video here so that you have some time to work these out. Alright, so first one here, we look, is there a GCF? There is no GCF between 4, 9, and x squared is only in one term. So then we look and we see that we have two terms, and then we also see that we have a difference. So we're going to try difference of two squares. So then what squares to give us 4x squared? That is 2x. And then what squares to give us 9? And that is 3. Let me write those down. 2x and 3. 2x and 3 make one positive, one negative. So remember, that's what we call difference of two squares. Hey, this next one here, there is no GCF. And there's three terms, so we're going to try x box. There's my x, I get 25 on top. And 10 on the bottom, so what multiplies to 25 and adds to 10? We get 5 and 5. We do our box. And x squared, 25, 5x, and 5x. So we look for our GCF in each of these, so that is 5, that is x. This way is x, and this one is 5. So we get x plus 5 times x plus 5, or that can be written as x plus 5 squared. Now, what is this specifically called? So this is called a perfect square trinomial because we end up with the same factors. As far as solving, you can see that it makes no difference that you know that. Unlike the difference of two squares, it makes it simpler if you can identify that. But identifying it's a perfect square trinomial doesn't really change a whole lot. I sometimes recognize it, sometimes I'll just X box it as well. And so it's about the same. Alright, third one here. X squared minus 144. There is no GCF. We have two terms. We have a difference this time again. And so what squares to give us x squared? That is x. And what squares to give us 144? That is 12. So then we get x and 12, x and 12. Make one positive, one negative. Again, doesn't matter which one you do first. I can make this one positive, and then make this one over here negative, and it all works the same. Alright, and last one here. Let's X box this one here. And so now our A is 16, so 16 times 1 is 16, and then our B is negative 8. What multiplies 16 adds to negative 8, that is negative 4 and negative 4. Do our box. And we get 16x squared and 1. Remember that it is this value that goes down here and this value that goes here, not this 16 here. We made some of those mistakes the first time through. We got better when it came to the test, so let's get a little bit better and not make that mistake anymore. And then we get negative 4x and negative 4x. Then we look at our GCF. We have 1 there, we have 4x there, 4x there, and 1 there. Now, we have these negatives here, which means these are going to be negative on the outside, because as we can double check our work, 4x times 4x is 16x squared. 4x times 1 would have been 4x, but 4x times a negative 1 is negative 4x. 4x times a negative 1 is negative 4x, and negative 1 times negative 1 is 1. So don't forget, when we have a negative on the outside there, and there, we need to pull that negative out, and then that gives us 4x minus 1 times 4x minus 1, or 4x minus 1 squared. Alright, so what I want you to do is we'll have this round robin when we come into class. Listen the 4 steps to solve by factoring, which we did previously in 8182. Alright, so what I want you to do is now go ahead and practice these problems. So pause here so you have time to work through these. Don't forget to do GCF, difference squares, all that. Make sure you get it set equal to 0. All our steps to factoring. Alright, so look at number 1 here. No GCF. It's already set equal to 0. 3 terms, so we're going to X box. So draw my X. And 4 times 9 is 36. And then we get 12 on the bottom. What multiplies 36 and adds to 12? That is 6 and 6. Draw our box. And so we get 4x squared here, 9 there, 6x and 6x. I get 3 there, 2x there, 2x there, and 3 there. So then we get 2x plus 3 times 2x plus 3. And since we're solving, we'll leave them as separate. And our next set of notes, we'll learn how to deal with it when we put them together. So we go 2x plus 3 equals 0, and 2x plus 3 equals 0, because our step is to set each of our factors equal to 0. And then from here, subtract 3, and then divide by 2, and we get x equals negative 3 halves. Now if we solve the same over here, notice that we will get the same answer. Now, is there 2 answers or just 1? And so we have 2x equals, but it is the same value, which means that really there's just the one answer, x equals negative 3 halves, okay, which we'll talk about here in a little bit what that means. Graphically, it does have some implications, but solving wise, you don't have to write x equals negative 3 halves and x equals negative 3 halves. You can just write it once. That is totally okay. Alright, let's look at the third one here, number 3. So as we look at this, is there a GCF? There is. Our GCF is 2, because 2 goes into 8 and 2, and then also we have some x's in common. We have 4 in the first one and 2 in the second one, so that means we have 2 x's total that I can factor out, and that leaves me with 4x squared minus 1 equals 0. Now we factor what's inside our parentheses, and so we have 2 terms, and with that, our GCF, so what factors to give us 4x squared? That is 2x, and you can do it like I did previously, where you write the parentheses squared equals 4x squared. Some of you guys are getting to the point where you just write this down, and then what squares to give you 1, that's 1, and 1, make 1 positive, 1 negative, set that equal to 0. Now, just like we did before, you set each of your factors equal to 0, and a lot of students will do this. 2x plus 1 equals 0, 2x minus 1 equals 0, and that's totally okay. But the issue they forgot is our GCF is still a factor. So 2x squared equals 0. Okay, so then divide by 2 on this one, and you get x squared equals 0. And then we solve by taking the square root. That's how we get rid of x squareds. And we get x equals 0 for that one. So here we subtract 1. And you get 2x equals negative 1. Divide by 2. And x equals negative 1/2. And then we solve for our third one. So we get plus 1. 2x equals 1. Divide by 2. And x equals positive 1/2. So we have 3 answers here. X equals 0, x equals negative 1/2, and x equals 1/2. And we'll talk about how many answers you can expect in a little bit. Here, this x equals 0 is actually a double, what they call a double root. And again, when we talk about some graphs and show that, you will see what that means as well. Alright, so moving on to number 2 and 4 over here. So number 2 is not set equal to 0, so I'm going to subtract the 1 to get it set equal to 0 first. And then there is no GCF. There's 2 terms, so we look for a difference. There is. We look for our 2 squares. So what squares to give me 25x squared? That is 5x. And what squares to give me 1? That is 1. Make 1 positive, 1 negative. Set those equal to 0. Solve, subtract 1. Divide by 5. And x equals negative 1/5. And then over here we're adding 1. Dividing by 5. And x equals 1/5. So we get negative 1/5 and 1/5. Now, on these, sometimes you may see your answer written like this, plus or minus 1/5. Same idea, just a different way of writing what that answer is. Alright, number 4. Alright, so we look at this, it's not set equal to 0, so I'm going to add 108 over. There's no like terms to combine it, so we get 3x squared minus 36x plus 108. Now I look for a GCF. This time there is a GCF. It's a GCF of 3. So then I get x squared minus 12x plus 36. And then that 3, we can do a couple things with it. So we can divide by 3. And that 3 cancels out. 0 divided by 3 is just 0. And we get x squared minus 12x plus 36. The other thing that could have been done is we just leave it, and then I'll show you how it plays in when we have our factors and we're solving. And you can see why dividing this one out works, where when we had on number 3 over here, why we can't just divide the 2x squared out. Alright, so as we look at this here, we're going to factor what's inside now, and so I get 36 on top, negative 12 on bottom. That gives me negative 6 and negative 6, which then means my factors for this are now 3. Oh, let's do the box first. Let's go x squared, negative 36, negative 6x, negative 6x. Pull our GCFs out. We get negative 6, we get x, and negative 6. So x minus 6 and x minus 6 equals 0. Now we set all our factors. So the first one, 3 equals 0. Well, does 3 equal 0? No. So that's why it has no impact. That's why we could have just divided everything by 3 and got rid of it. On number 2, the reason that one had an answer is because it had an x involved in it. So x could equal 0, but 3 cannot equal 0. And then here we get x minus 6 equals 0. X minus 6 equals 0. We recognize that only one needs to be answered because it ends up being the same, so we get x plus 6. Now, we could have written it as x minus 6 squared equals 0, and we'll get in a little bit of that in 9.1, but just like with x squared equals 0, we take the square root. Here we're going to take the square root as well. That gives us x minus 6 equals 0, which we already saw is x equals 6 as our final answer. Alright, so we'll discuss this when we come back into class, but the question I want you to jot down a couple notes on are what changed in the process when solving with special factors. So what changed from 8182 to 83? Alright, solving equation models with special factors. So we have a word problem here, and it says, as a satellite falls from outer space onto Mars, its distance in miles from the planet is given by the formula d equals negative 9t squared plus 776, where t is the number of hours it has fallen. Find when the satellite will be 200 miles away from Mars. Okay, so what we want to do is initially we want to identify the important information. Word problems, they give you a lot and sometimes a little too much. So let's identify specifically what we need to know. So the satellite's distance in miles is given by the formula d equals negative 9t squared plus 776. And the satellite distance at some time t is d 200 miles. Okay. And then so we want to formulate a plan. So by substituting the value of the constant d equals 200 into our equation, d equals negative 9t squared plus 776, we get 200 equals negative 9t squared plus 776. So then what we want to do is we want to solve, and so in order to do that, we are going to get it set equal to 0 first. Now normally I always try to make first term positive, but it is a little simpler to subtract 200, and it's not a bad practice how to deal with when your a is negative. So we'll see how that works out. So I'm going to subtract 200 to get it set equal to 0, and you get negative 9t squared plus 576. Now from here we want to check to see if there's a GCF. Alright, so we have a GCF of 9 here, and so what I'm going to do is I'm going to factor out a negative 9 so that we get a positive value, and then this becomes negative as well. Because if we hadn't factored out that negative 9, it wouldn't have looked how we normally are used to a difference of squares. We would have had a negative, but it would have been on our first term, and a positive on our second term. And so factoring that negative 9 out then gives us the traditional difference of squares. Like we saw before, we can divide that negative 9 out because it's not going to play a part in our answer. So then we get 0 equals t squared minus 64. So then what squares to give us t squared? That is t. And what squares to give us 64? That is 8. Make one positive, one negative. Set that equal to 0. Solve by setting each term equal to 0. And you get t equals plus or minus 8. Alright, so we solved, and so the equation contains a GCF of 9, and we factor out a negative 9, and then we want to use the zero product property. Okay, remember that's where we put t minus 8 equal to 0 and t plus 8 equal to 0. That's what allows us to set each of those equal to 0. And the answer is t equals 8, because remember we had t equals negative 8 and 8, because time must be positive. Okay, even though we solved for a negative 8, we got to put that back into context. So theoretically, 8 and negative 8 are solutions. But in the context of this real world problem, we're talking about time, and time can't be negative. So the satellite has fallen for 8 hours. And so t equals 8 makes sense because time must be positive. And then we want to check that by substituting the value of t into the original equation. So t goes into there. So you get negative 9 times 64 plus 776. And then negative 9 times 64 is a negative 576 plus 776. When you combine those, you get 200, which is what our original distance that we wanted. Alright, so your turn. Your quizzes is posted on Classroom. Make sure you complete that before you come into class tomorrow. And with that, remember you do well on it because you're graded partially on effort and correctness. So take some time, go back and look at the notes as needed to complete this. Alright, and then our essential question that we'll talk about when we come in is how can you use special products to aid in solving quadratic equations by factoring? Exactly what we've done this whole section. Just kind of have your answer so we can briefly discuss it in class. And then your homework assignment, if you want to get a head start on it, we will spend most of the time in class working on it as well.